Here we're asked to solve a rational equation. In this case, we have a single algebraic fraction equal to another single algebraic fraction. When that's the case, we can solve using cross multiplication. But before we do that, let's determine the restrictions. Now, to find the restrictions, we set the denominators equal to 0. So in this case, x minus 1 equals 0 tells me x equals 1 is a restriction. Now we can do the same thing with 2x minus 5. Setting that equal to 0, we can see that x equals 5 halves is a restriction. Now this is important because cross multiplying introduces the possibility for extraneous solutions. Now, before we cross multiply, let's be careful with this negative here in front of this fraction. Okay, so here I'm going to write negative 1 in the numerator times x minus 4. Now with this, we're ready to cross multiply. So we can say 2 times 2x minus 5 times 2x minus 5 will have to equal negative x minus 4 times x minus 1. And so we can solve this equation as usual. Let's begin by distributing. That'll leave us with 2 times 4x squared minus 10x minus 10x plus 25 equals negative x squared minus x minus 4x plus 4. Now before I distribute, let me go ahead and add these like terms. So we have 2 times 4x squared minus 20x plus 25 equals negative x squared minus 5x plus 4. Now we'll go ahead and distribute the 2, leaving us with 8x squared minus 40x plus 50 equals negative x squared plus 5x, right, minus 4. Now at this point, to obtain standard form for this quadratic and get it equal to 0, we'll go ahead and add x squared. So that'll give us 9x squared, subtracting 5, minus 45x, and then adding 4, we have plus 54 equals 0. Now I notice there's a GCF, so let's go ahead and factor out the 9. We have x squared minus 5x plus 6, and that'll be equal to 0. Factoring further, x squared factors x times x. 6 factors 2 times 3. 2x and 3x add up to negative 5x if they're both negative, and then negative 2 times negative 3 is positive 6. Okay, so at this point we set each variable factor equal to 0. So x minus 2 equals 0 or x minus 3 equals 0. And that tells me my two solutions are x equals 2 or x equals 3. Now remember, cross multiplying introduces the possibility for extraneous solutions, so we have to check our answers in the original equation. But in this case, the restrictions were that x were not allowed to be 1 or 5 halves. And since our answers are not restrictions, they'll work.